Hello students, this is one of the important harsh question. Another paper is very tough, you can expect this type of question, and this result is very important for 12th standard maths, CBSE maths. First, the given condition is a square plus b square plus c square minus ab minus bc minus ca equal to 0. Using this result, prove that a equal to b equal to c. Okay. Now, a square plus b square plus c square minus ab minus bc equal to 0. You can't apply any identity here. Reason is the coefficient of a, b, b, c, ca is 1. That is here minus 1. But if you want to apply square of binomial, whether it is a plus b whole square or a minus b whole square, the coefficient of ab is always either 2 or minus 2. So 2 is not there. Okay. So don't forget this important step. So multiply both sides by what? 2. Clear. What is the reason for minus 2? Because we need 2 for the coefficient of a, b or b, c or ca. So this implies 2a square, 2b square, 2c square minus 2ab minus 2bc minus 2ca equal to 2 into 0. Clear. Now group the terms and you have to split into two cases, 1a square minus 2ab plus b square and another from 2b square 1b square minus 2bc, from 2c square take 1c square plus from 2c square 1c square minus 2ca, and here very important, this is a square, see here this is 1b square another b square, this is 1c square another c square, similarly a square and last plus a square equal to 0, 2 into 0 0. So what is the value of the first group? A minus b the whole square plus b minus c the whole square plus c minus a the whole square equal to 0. So one of the very important stage, a minus b whole square plus b minus c whole square plus c minus a whole square equal to 0, which implies a minus b equal to 0, b minus c equal to 0, c minus a equal to 0. How? I will explain. X square plus y square equal to 0 means only when x equal to 0 and y equal to 0. Our x and y are real numbers, this is possible only when both are 0. Similarly here, square of first term plus square of second term plus square of third term is 0 means the value of each term is always 0, which implies a equal to b or b equal to c and c equal to a. Clear. If you compare all the three expressions, if you compare a equal to b, b equal to c, c equal to a, which implies a equal to b equal to c. That's all. That is required to prove. Don't forget this step. Y by 2, if you multiply by 2, you will get 2ab, 2bc, 2ca. Then only you can apply this formula. And also 2a square, 1a square for the first group and another a square for the third group. And 2b square, 1b square for this term, another b square for second group. 2c square, 1c square for second group, another c square for third term. So all the term gets balanced. So this is a minus b whole square plus b minus c whole square plus c minus a whole square, which implies using this concept of x square plus y square equal to 0 implies x equal to 0 and y equal to 0. So first term equal to 0, second term equal to 0, third term equal to 0, and solution of this is a equal to b, b equal to c, c equal to a. If we combine all the three cases, a equal to b equal to c. One of the very tough 3-mark question in square of binomial x. But you can expect the same question in board exam. Okay, thank you.